Application scaling on IBM Bluemix. When you run an application on the cloud, you expect it to be able to scale. Previously, we talked about the characteristics of a 12-factor application. Those aspects of application design focus on steps to follow to ensure that your application is ready to scale. In this module, you will learn about some of the features available on Bluemix Platform as a Service to implement the actual operation of scaling your application. We'll start off by describing types of scaling, and then cover how you manually and automatically scale a Bluemix Cloud Foundry application. The cloud empowers you to adjust your computing resources to meet your load requirements. Capacity can be altered both manually, by executing a command on a command line or through a web interface, and programmatically, through predefined changes in capacity or through software that automatically adjusts capacity to meet actual demand. A major value to adopting cloud computing is to be able to exploit inherent elasticity, that is, the ability to consume more or less resource on demand and through a pay-per-usage model. Elasticity is such a critical differentiator for cloud computing that Amazon named their infrastructure as a service offering EC2 for Elastic Compute Cloud. The ability to manually adjust capacity is a huge advantage over traditional computing, but the real power of scaling in the cloud lies in dynamic scaling. There are different ways to accomplish scaling. One is vertical scaling, and the other is horizontal scaling. What is the difference between the two? Vertical scaling is often referred to as scaling up. Vertical scaling increases the resources available to an application by adding capacity directly to the individual nodes. Horizontal scaling is often referred to as scaling out. You grow the overall application resource capacity by adding more nodes. Let's look at examples of each. Vertical scaling is an action taken to increase the resources available to an application by adding resources to the system hosting a specific application instance runtime. For example, additional memory or CPU cores could be added to the hosting system. Depending on the environment hosting the application instance, sometimes vertical scaling can be performed on the fly without affecting the running application whatsoever. In other cases, vertical scaling is accomplished by restarting the system hosting the application, followed by restarting the application. In other cases, it can achieve by dynamically moving the application instance to a new hosting system with the increased resources. Regardless of how it is accomplished, there is little to nothing that typical applications need to do to be able to exploit the additional capacity. This makes vertical scaling painless from the point of view of the application developer. However, a major downside is that eventually you will always run out of resources to add, and potentially in pretty short order, and the upper limit is set by the size of the hosting server. Horizontal scaling is the ability to scale with increasing application traffic by adding more application instance nodes. Each additional node has similar memory and CPU resources. Since horizontal scaling simply requires spinning up a new instance and routing traffic through a load balancer to the additional instance or instances, there usually is no downtime associated with a horizontal scaling action. Cloud applications need to be designed around certain patterns, for example, as outlined in the 12-factor app methodology, in order to be ready to be horizontally scaled. Fortunately, in many cases, adhering to these patterns is pretty easy for many types of applications. Unlike vertical scaling, you can get a lot of capacity in horizontal fashion, and you could even gain geographic diversity as you add capacity horizontally by adding instances in another geography or location. IBM Bluemix provides controls in the Web UI or through the CLI to perform both horizontal and vertical scaling of Cloud Foundry applications. The illustration shows the controls for the Web UI. Horizontal scaling, up or down, by adding or removing instances can be performed without any application downtime. Vertical scaling for Cloud Foundry applications in the Web UI only includes memory allocation to the instance. When changing the memory allocation, there is downtime as the application instances are stopped and redeployed on updated cells. It's important to note that for either type of scaling, if the application manifest specifies a different amount of resources, if the application is redeployed, the application manifest settings will supersede any manual scaling through the Web UI or CLI. Bluemix DevOps includes an auto-scaling service for Cloud Foundry runtimes. The auto-scaling service performs horizontal scaling operations only. To use it with an application, deploy it from the catalog, and bind it to the application, and set a scaling policy. A scaling policy is composed of rules that contain instructions for triggering scaling activities. For Liberty for Java applications, you can define scaling rules on JVM heap, memory, response time, and throughput. For Node.js applications, you can define scaling rules for heap, memory, and throughput. For Swift applications, you can define rules on memory, throughput, and response time. And for Ruby applications, you can define scaling rules for memory. You can define multiple scaling rules for more than one metric type. However, the auto-scaling service does not detect conflicts between scaling policies. When you define the scaling policy, you must ensure that the multiple scaling rules do not conflict with one another when the application scales in or scales out. There are some important parameters to understand when setting a scaling policy. The breach duration is the time window used to determine if a deviation from the policy threshold will trigger the scaling action specified in the rule. If you want to respond quickly to a violation of the threshold, set the breach duration to a smaller value. After a scaling action is taken, a subsequent action is not taken until after the cooldown time period passes. This parameter is used to provide enough time for the application metric to stabilize after a scaling action. You can specify a short time period for cooldown for fast response and testing purposes, and then use a longer period for a production environment to avoid excessive instance scaling activity. You can also specify a minimum and maximum number of instances. You might want to have a minimum of 2 to avoid downtime in case an application instance crashes. The remaining instance could handle traffic while the other restarts. And you may want to set a maximum to avoid a condition where an undesired number of instances are started in case of a problem with the application or its metrics. The auto-scaling service control panel includes a metric statistics tab. Here, you can see a display of the metric statistics for the instances of your application. You can see both the average statistics and select a specific instance to see its statistics for each available metric. The dial and the graphs are color-coded based upon how the metric aligns to any currently configured scaling policy thresholds. The auto-scaling service also includes a panel displaying previous scaling activity for your applications. It supports filtering based upon time intervals. For example, preset items for past week displays a scaling history for the past week, or past month, which displays a scaling history for the past month, or a custom range, where you can specify the time period. Note, you can also filter the history records by selecting as desired the scaling status or scaling in/out values. You can use the scaling history as one way to monitor an application resource and its metrics performance. And this concludes our overview of application scaling support in the cloud on IBM Bluemix. Thanks for watching.